Chemical Reactions and Equations. CBSE Class 10 Science, Chapter 1, Notes. What is a chemical reaction? Chemical reaction. The transformation of chemical substance into another chemical substance is known as chemical reaction. For example, rusting of iron, the setting of milk into curd, digestion of food, respiration, etc. In a chemical reaction, a new substance is formed which is completely different in properties from the original substance. So, in a chemical reaction, a chemical change takes place. Only a rearrangement of items takes place in a chemical reaction. The substances which take part in a chemical reaction are called reactants. The new substances produced as a result of chemical reaction are called products. Example, the burning of magnesium in the air to form magnesium oxide is an example of a chemical reaction. 2 Mg into solid state plus O2 into gaseous state gives 2 MgO in solid state. Before burning in air, the magnesium ribbon is cleaned by rubbing with sandpaper. This is done to remove the protective layer of basic magnesium carbonate from the surface of the magnesium ribbon. Reactant. Substances which take part in a chemical reaction are called reactants. Example, magnesium, that is Mg, and O2, that is oxygen. Product. A new substance formed after a chemical reaction is called a product. For example, MgO, that is magnesium oxide. Let's see the characteristics of chemical reactions. First, evolution of gas. The chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Zn plus H2SO4 gives ZnSO4 plus H2 in gaseous state. Number 2. Change in color. The chemical reaction between citric acid and purple-colored potassium permanganate solution is characterized by a change in color from purple to colorless. The chemical reaction between sulfur dioxide gas and acidified potassium dichromate solution is characterized by a change in color from orange to green. Number 3. Change in state of substance. The combustion reaction of candle wax is characterized by a change in state from solid to liquid and gas because wax is a solid. Water formed by the combustion of wax is a liquid at room temperature, whereas carbon dioxide produced by the combustion of wax is gas. There are some chemical reactions which can show more than one characteristics. Number 4. Change in temperature. The chemical reaction between quicklime water to form slacked lime is characterized by a change in temperature, which is a rise in temperature. The chemical reaction between zinc granules and dilute sulfuric acid is also characterized by a change in temperature, which is a rise in temperature. Number 5. Formation of precipitate. The chemical reaction between sulfuric acid and barium chloride solution is characterized by the formation of a white precipitate of barium sulfate. BaCl2 aqueous plus H2SO4 aqueous gives BaSO4 solid in precipitate plus 2HCl in aqueous state. Let's see what is a chemical reaction or a chemical equation. Representation of chemical reaction using symbols and formulae of the substances is called a chemical equation. For example, as A plus B gives C plus D. In this equation, A and B are called reactants and C and D are called products. The arrow shows the direction of chemical reaction. Condition, if any, is written generally above the arrow. When hydrogen reacts with oxygen, it gives water. This reaction can be represented by the following chemical equation. Hydrogen plus oxygen gives water. H2 plus O2 gives H2O. In the first equation, words are used, and in second, symbols of substances are used to write the chemical equation. For convenience, the symbol of substance is used to represent chemical equations. A chemical equation is a way to represent the chemical reaction in a conscious and informative way. A chemical equation can be divided into two types: balanced chemical equation and unbalanced chemical equation. What is a balanced chemical equation? A balanced chemical equation has the number of atoms of each element equal on both sides. For example, Zn plus H2SO4 gives ZnSO4 plus H2. In this equation, number of zinc, hydrogen and sulfate are equal on both sides. So it is balanced chemical equation. According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. To obey this law, the total mass of elements present in reactants must be equal to the total mass of elements present in products. Now let's look at the unbalanced chemical equation. If the number of atoms of each element in reactants not equal to number of atoms of each element present in the product, then the chemical equation is called unbalanced chemical equation. For example, Fe plus H2O gives Fe3O4 plus H2. In this example, a number of atoms of elements are not equal on two sides of the reaction. For example, on the left hand side, only one iron atom is present, while three iron atoms are present on the right hand side. Therefore, it is an unbalanced chemical equation. Now let's look at balancing a chemical equation. To balance the given or any chemical equation, follow these steps. Fe plus H2O gives Fe3O4 plus H2. Write the number of atoms of elements present in reactants and in products in a table as shown here. So as we can see in this table, the number of atoms are given in reactant and in product. Iron in reactant 1 and a number of atoms in product 3. Hydrogen 2 and 2 and oxygen 1 and 4. Balance the atom which is maximum in number on either side of the chemical equation. In this equation, the number of oxygen atom is the maximum on RHS. To balance the equation, one needs to multiply the oxygen on LHS by 4 so that the number of oxygen atoms becomes equal on both sides. Fe plus 4 into H2O gives Fe3O4 plus H2. Now, the number of hydrogen atom becomes 8 on LHS, which is more than that of RHS. To balance it, one needs to multiply the hydrogen on the RHS by 4. Fe plus 4 into H2O gives Fe3O4 plus 4 into H2. After that, the number of oxygen and hydrogen atoms becomes equal on both sides. The number of iron is 1 on the LHS while it is 3 on the RHS. To balance it, multiply the iron on the LHS by 3. So 3 into Fe plus 4 into H2O gives Fe3O4 plus 4 into H2. Now, the number of atoms of each element becomes equal on both sides. Thus, this equation becomes a balanced equation. So, let's look at the table. Iron atoms in the reactant are 3 and in product are 3. and same as for hydrogen and oxygen, respectively. For hydrogen it is 8 and 8, and for oxygen it is 4 and 4. That means they are equal in reactant as well as in product. So after balancing, the above equation can be written as follows: 3Fe plus 4H2O gives Fe3O4 plus 4H2. To make equations more informative, what we can do? Writing the symbol of physical states of substances in chemical equation. By writing physical states of substances in a chemical equation becomes more informative. Gaseous state is represented by symbol G into bracket. Liquid state is represented by symbol small l in the bracket. Solid state is written by symbol small s in bracket. Aqueous solution is written by symbol AQ in the bracket. Writing the condition in which reaction takes place. The condition is generally written above and or below the arrow of the chemical equation. Thus, by writing the symbols of the physical state of substances and condition under which reaction takes place, a chemical equation can be more informative. So let's look at the types of chemical reaction. So chemical reactions can be classified into following types. Number one, combination reaction. Reaction in which two or more reactant combine to form one product are called combination reactions. A general combination reaction can be represented by the chemical equation given here. A plus B gives AB. Examples: when magnesium is burnt in the air, oxygen, magnesium oxide is formed. In this reaction, magnesium is combined with oxygen in air. So magnesium in solid state plus oxygen in gaseous state gives 2MgO. Magnesium plus oxygen gives magnesium oxide. When carbon is burnt in oxygen in presence of air, carbon dioxide is formed. In this reaction, carbon is combined with oxygen. C in solid state plus O2 in gaseous state gives CO2 in gaseous state. In words, carbon plus oxygen gives carbon dioxide. The second type of chemical reaction is decomposition reaction. The reaction in which one compound decomposes in two or more compounds or elements are known as decomposition reaction. A decomposition reaction is just the opposite of combination reaction. A general decomposition reaction can be represented as follows: AB gives A plus B. Examples: when calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. CaCO3 in solid state in presence of heat gives CaO in solid state plus CO2 in gaseous state. In words, calcium carbonate gives calcium oxide plus carbon dioxide. When ferric oxide is heated, it decomposes into ferric oxide and water. 2FeOH thrice in solid state gives Fe2O3 in solid state plus H2O in liquid state. Next type is thermal decomposition. The decomposition of a substance on heating is known as thermal decomposition. The example for this is 2PbNO3 twice in solid state in presence of heat gives 2PbO in solid state plus 4NO2 in gaseous state plus O2 in gaseous state. Now let's look at the electrolytic decomposition. Reactions in which compounds decompose into simpler compounds become because of passing the electricity are known as electrolytic decomposition. This is also known as electrolysis. Example: when electricity is passed in water, it decomposes into hydrogen and oxygen. 2H2O in liquid state gives H2 in gaseous state plus O2 in gaseous state. So what are photolysis or photodecomposition reactions? The reaction in which compound decomposes because of sunlight are known as photolysis. We all know photo means light, or photodecomposition reaction. Example, when silver chloride is put in sunlight, it decomposes into silver metal and chlorine gas. 2AgCl in solid state, which is white in color, when kept in sunlight gives 2Ag into solid state, which is gray in color, plus Cl2 in gaseous state. Photographic paper has a coat of silver chloride which turns into gray when exposed to sunlight. It happens because silver chloride is colorless while silver is a gray metal. So let's look at the third type, that is displacement reaction. The chemical reactions in which a more reactive element displaces a less reactive element from a compound is known as displacement reactions. Displacement reactions are also known as substitution reaction or single displace or replacement reactions. A general displacement reaction can be presented by using a chemical equation as follows. A plus BC gives AC plus B. Displacement reaction takes place only when A is more reactive than B. If B is more reactive than A, then A will not displace C from BC, and reaction will not be taking place. Let's see the examples. When zinc react with hydrochloric acid, it gives hydrogen gas and zinc chloride. Zn into solid state plus 2HCl in aqueous state gives ZnCl2 in aqueous state plus H2 in gaseous state. When zinc react with copper sulfate, it forms zinc sulfate and copper metal. Zn in solid state plus CuSO4 in aqueous state gives ZnSO4 in aqueous state plus copper in solid state. The fourth type of chemical reaction is double displacement reaction. Reaction in which ions are exchanged between two reactants forming new compounds are called double displacement reaction. Means what? AB plus CD gives AC plus BD. Now let's look at the examples. When a solution of barium chloride reacts with the solution of sodium sulfate, white precipitate of barium sulfate is formed along with sodium chloride. BaCl2 in aqueous form plus Na2SO4 in aqueous form gives BaSO4 in solid state, that is a precipitate, plus 2NaCl in aqueous form. When sodium hydroxide, which is a base, react with hydrochloric acid, sodium chloride and water are formed. NaOH aqueous plus HCl aqueous gives NaCl aqueous plus H2O in liquid form. Note that displacement reaction, double displacement reaction in which precipitate is formed is also known as precipitation reaction. Neutralization reaction are also example of double displacement reaction. So let's look at the precipitation reaction. The reaction in which precipitate is formed by mixing of aqueous solution of two salts is called precipitation reaction. For example, AgNO3 aqueous plus NaCl aqueous gives AgCl in solid state plus NaNO3 in aqueous. In words, silver nitrate and sodium chloride in precipitate form gives silver chloride and sodium nitrate. Neutralization reaction, the reaction in which an acid reacts with a base to form salt and water by an exchange of ion, is called neutralization reaction. For example, NaOH aqueous plus HCl aqueous gives NaCl aqueous plus H2O liquid. That is, sodium hydroxide plus hydrochloric acid gives sodium chloride and water. The fifth type of chemical reaction are oxidation and reduction reaction. So let's look at what is oxidation. Addition of oxygen or non-metallic element or removal of hydrogen or metallic element from a compound is known as oxidation. Elements or compounds in which oxygen or non-metallic element is added or hydrogen or metallic element is removed are called to be oxidized. And reduction, addition of hydrogen or metallic element or removal of oxygen or non-metallic element from a compound is called reduction. The compound or element which goes under reduction is called to be reduced. So oxidation and reduction takes place together. So what is oxidizing agent and reducing agent? The substance which gives oxygen for oxidation is called oxidizing agent, and the substance which removes hydrogen is also called oxidizing agent. Reducing agent, the substance which gives hydrogen for reduction is called reducing agent. The substance which removes oxygen is also called a reducing agent. So the reaction in which oxidation and reduction both take place simultaneously is called redox reaction. When copper oxide is heated with hydrogen, then copper metal and hydrogen are formed. CuO plus H2 gives Cu plus H2O. In this reaction, CuO is changing into Cu. That means oxygen is being removed from copper oxide. Removal of oxygen from a substance is called reduction. So, copper oxide is being reduced to copper. In this reaction, hydrogen is changing to H2O, means oxygen is being added to hydrogen. The addition of oxygen to a substance is called oxidation. So, hydrogen is being oxidized to water. The substance which get oxidized is reducing agent and substance which get reduced is oxidizing agent. Now let's look at the next type of chemical reaction, that is exothermic and endothermic reaction. First type, exothermic reaction. The reaction which produces energy is called exothermic reaction. Most of the decomposition reactions are exothermic. For example, respiration is a decomposition reaction in which energy is released. C6H12O6 in aqueous form plus 6O2 gives 6CO2 in gaseous state plus 6H2O in liquid state plus energy. In words, glucose plus oxygen gives carbon dioxide and water. When quicklime or CaO is added to water, it releases energy. CaO in solid state plus H2O in liquid state gives CaOH twice in aqueous state plus energy. That is, quicklime and water gives calcium hydroxide, which is also known as slacked lime. What is endothermic reaction? A chemical reaction in which heat energy is absorbed is called endothermic reaction. For example, decomposition of calcium carbonate. means CaCO3 in solid state in presence of heat gives CaO in solid state plus CO2 in gaseous state. Calcium carbonate gives calcium oxide plus carbon dioxide. Now let's look at the effects of oxidation reactions in everyday life, that is corrosion and rancidity. What is corrosion? The process of slow conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acids, gases, etc. present in the atmosphere is called corrosion. For example, rusting of iron. What is rusting? Iron, when react with oxygen and moisture, forms red substance which is called rust. 4Fe into solid state plus 3O2 in gaseous state plus H2O in liquid state gives 2Fe2O3 plus dot H2O in solid state, which is rust, or also known as hydrated ferric oxide. The rusting of iron is a redox reaction. So corrosion or rusting weakens the iron and steel objects and structures such as railing, car bodies, bridges and ships, etc. and cut shorts their life. Methods to prevent rusting are by painting, by greasing and oiling, and by galvanization. Now let's see the corrosion of copper. Copper objects lose their luster and shine after some time because the surface of these objects acquires a green coating of basic copper carbonate CuCO3 dot CuOH twice when exposed to air. Let's see the equation for this. 2Cu into solid state plus CO2 in gaseous state plus O2 in gaseous state plus H2O in liquid state gives CuCO3 CuOH twice. Copper in moist air gives basic copper carbonate which is green in color. Let's look at the corrosion of silver metal. The surface of silver metal gets tarnished or becomes dull on exposure of air due to the formation of a coating of black silver sulfide, that is Ag2S, on its surface by the action of H2S gas present in the air. 2Cu into solid state plus H2O in gaseous state gives Ag2S in solid state, gaseous state plus H2O in gaseous state. Silver and hydrogen sulfide gives silver sulfide, that is black in color. Now what is rancidity? The taste and odor of food materials containing fat and oil changes when they are left exposed to air for a long time. This is called rancidity. It is caused due to the oxidation of fat and oil present in food materials. Methods to prevent rancidity are as follows: by adding antioxidant, vacuum packing, replacing air by nitrogen, or refrigeration of foodstuff. Let's look at the summary of this chapter. Chemical reaction. During chemical reaction, the chemical composition of substances changes or new substances are formed. Chemical reactions can be written in chemical equation form, which should always be balanced. Type of chemical reactions. Combination reaction. A single product is formed from two or more reactants. 2Mg plus O2 gives 2MgO. Decomposition reaction. A single reactant breaks down to yield two or more products. There are subtypes. Thermal decomposition. 2PbNO2 twice gives 2PbO plus 4NO2 plus O2. Electrolysis. 2H2O gives 2H2 plus O2. Photochemical reaction. 2 AgBr gives 2 Ag plus Br2. Displacement reaction. One element is displaced by another element. Zn plus CuSO4 gives ZnSO4 plus Cu. Double displacement reaction. Exchange of ions between reactants. AgNO3 plus NaCl gives AgCl plus NaNO3. Redox reaction. Both oxidation and reduction takes place simultaneously. CuO plus H2 gives Cu plus H2O. Exothermic reaction. A chemical reaction in which heat energy is evolved. C plus O2 gives CO2 in gaseous state plus heat. Endothermic reaction. A chemical reaction in which heat energy is absorbed. ZnCO3 plus H heat gives ZnO plus CO2. Redox reaction. Chemical reaction in which both oxidation and reduction takes place simultaneously. Oxidation, the reaction which involves the gain of oxygen or loss of hydrogen. Reduction, the reaction that shows loss of oxygen or gain of hydrogen. ZnO plus C gives Zn plus Co. ZnO is reduced to Zn, that is reduction, and C, that is carbon, is oxidized to Co, that is oxidation. Now let's look at the effects of oxidation reaction in our daily life. Corrosion. It is an undesirable change that occurs in metals when they are attacked by moisture, air, acids and bases. For example, corrosion or rusting of iron Fe2O3 NH2O, that is hydrated iron oxide. Rancidity, undesirable changes that takes place in oil containing food items due to the oxidation of fatty acids. Preventive methods of rancidity: adding antioxidants to the food material, storing food in the airtight container, flushing out the air with nitrogen gas, and refrigeration.